Hello. Hello, Fawaz. Are you listening me?
Yes, sir. Yes.
Hmm. So today, first we will discuss the simple microscope. Okay. First, we will discuss the simple microscope. Okay. Basically, a simple microscope is a convex lens, and when you are placing the object uh, between the focus and the optical center of the lens, in that case of the convex lens is the case of the simple microscope. Okay, by the way, simple microscope, simple microscope, simple microscope. So simple microscope is so you have a, for a simple microscope we have a convex lens. This is a convex lens, and principal axis. Okay, and an object is placed like this between pole and the between the optical center and the focus of this lens. Okay, this is the principal axis. Okay, this is the principal axis. This is the principal axis. This is the convex lens in case of the simple microscope, and this is the object, and that object you want to see in the simple microscope. So how the simple microscopes works basically? So this is the object, so I am taking height of the object as ho. Ho is the ho is height of the object. Okay, okay. Before the simple microscopes, there are few things that I want to write. What is the microscope basically? First we should know what is microscope. So basically, a microscope is an optical instrument which magnifies the small object. What is the meaning of that? Magnifies the small object means a microscope is a device, okay, which forms a magnified or larger than the object image, okay, of the object. So you can write an optical instrument which magnifies a small object, magnifies a small object. So this is the microscope. Okay, now there is one more point that I want to write for average human being, means the least distant distance of the distinct vision, means the distance, the minimum distance up to which we can see the object is the least distance of distinct vision. The minimum distance up to which we can see the object is least distance of distinct vision. And that distance for a normal human being or average human being is 25 centimeter. And the maximum distance up to which a normal human being can see is infinity. Okay. So you can say that for a normal human being, this is the eye of a normal human being, and this eye minimum can see up to 25 centimeter, and this 25 centimeter is also the known as the near point. Okay, and the maximum distance up to which this eye can see is infinite, and this distance is known as the far point. Understanding for us, Hamza, Nida?
Yes,
Beta,
sir.
what I'm saying?
Yes, sir. You can continue.
Okay. So, okay. So basically, this is the eye. Okay. After that, there is a term that we will use in simple microscope, in compound microscope. We will use the term is the visual angle. Visual angle. Visual angle. Now, what is the visual angle? Basically, I will explain this with the help of one example. For example, there is an object. This is an object. And this is an object, and this is retina. Basically, this is eye. Okay, this is eye, and this is retina. Retina is behind, we know, and this is cornea. This part. So, by the way, what I want to say that visual angle is the angle formed by the object at eye. Simply. Okay, the angle formed at eye by the object or the image is the visual angle. For example, this theta will be the visual angle, and this can be any object or this can be any image. Okay, this is the object AB. So visual angle is the angle formed by object at eye. Formed by object at eye. Okay, this is the visual angle. So basically, the visual angle is representing the height of the object. If the height of the object will increase, then the visual angle will also increase. Okay, if suppose I am increasing the height of object like this, you can see here, height of the object is increased. then if with respect to this height, the visual angle will be this at I. So obviously this angle will be greater. Obviously this angle will be greater than the previous angle. Then you can say the visual angle, or you can say the height of the object is directly proportional to the visual angle. Okay, so you can say that height of object is directly proportional to the visual angle. Okay, and after that we will discuss the magnification of microscope. Earlier we discussed the magnification of mirror, we discussed magnification of the lens. Okay, now we will discuss what is the magnification in case of the microscope. So magnification of microscope. Magnification of microscope. And this magnification will be represented by capital M. So magnification of microscope is equal to the visual angle formed by final image divided by the visual angle formed by object at D. Now what is D? D is the least distance of distinct vision. Least distance of distinct vision. And what is this? This is equal to 25 centimeter for normal human eye. And how we calculate this? Very simple. We can calculate it like this. This visual angle formed actually represent both these angles, means visual angle formed by the final image is represented by beta, and visual angle formed by the object at D. D means least distance of the distinct vision is represented by alpha. So beta by alpha. Okay. Now beta you will get when you will see where will be the final image, and that final image, what angle is subtending on your eye, will be the beta. Now what is alpha? How we will calculate alpha? For calculating alpha, suppose at this point this is your eye. Okay, at this point the eye is there and the object is here. This is the object, and this object is at a distance of 25 centimeter. 25 centimeter at a distance of D. Okay, and this is the object. So if you will calculate this angle, this angle will be not beta, this angle will be alpha. Sorry, this angle will be alpha. This angle will be alpha. Okay. Or if image is forming like this, for example, if the image is formed like this, means the image is formed like this is the image, suppose. Okay, for example, if the image is this, then we will join this like this, suppose, and this angle will be the angle beta. In this way, I am just telling you how to calculate the magnification. Okay. So in this way, so now we will discuss the simple microscope. So what is microscope? I think it's clear now. Okay, all these things should be clear. This thing is very important, magnification of the microscope. Remember what is magnification of the microscope? Beta by alpha. Remember simply beta by alpha. What is beta? Visual angle formed by the final image. What is alpha? Alpha is this. Okay, alpha is this. And always na, when we will calculate alpha, this is object. So if you will take this height, you will take height of the object. Okay, so this is height of the object. So if you will calculate 10 alpha na from this triangle, so always you will get 10 alpha as HO by D, perpendicular by base, HO by D. Okay, so 10 alpha will be like this. And if this alpha is very small, then 10 alpha can be written as alpha, that we will do later. Okay, so first take the screenshot of this, then we will move further. Okay. Nida completed. Okay. Hamza completed. Okay. Okay. So magnification of microscope is equal to beta by alpha, visual angle formed by the final image, visual angle formed by the object at D. Now we will discuss the simple microscope. Simple microscope. So simple microscope is basically This is a convex lens. And for this convex lens, this is the principal. This is the principal axis, okay? And now an object is placed here. This is the object, okay? Now we'll draw the ray diagram. First ray from the object is parallel to the principal axis. Parallel to the principal axis. And after passing from the lens, it will pass from the focus like this. Oh. I told you that the lens we in our syllabus are very thin lenses, okay? So we can just draw a straight line here. Okay, so first ray is parallel to the principal axis, and after passing from the lens, it will pass from the focus of the lens. Another ray from the lens will be like this, is passing from the optical center and will pass straight. And if this ray is passing from the optical center, it is passing straight. Now both the rays are diverging, and diverging rays will never meet. Okay. So what we will do, we will produce these diverging rays in the backward direction. Like this. And where these diverging rays will meet, there will be the image. So somewhere here these rays will meet, and finally we will get the image here. So these are the produced rays. Okay. So this will be the image, and this was the object. So this will be the image, okay? This was the object. Now this magnified image will be produced of this object, okay? A simple microscope. Okay, so this is the image and this is the object. So I am taking height of the object, okay? HO. HO as the height of the object, and HI is the height of the image. Okay, and this is focus. And your eyes are watching from this side. Like this. And here you will see this image. Now we will calculate the magnification. We will calculate the magnification of the microscope, simple microscope. What is the formula for the magnification? I told you magnification is equal to beta by alpha. angle subtended by the final image means visual angle subtended by the final image divided by the visual angle when the object is at D. Okay, so final image is this final image is subtending this much angle. This much angle means how much angle? Means this angle. This angle will be beta, because this beta will be the angle subtended by the final image. Okay, and what is alpha? Alpha will be like this. Alpha will be always, I told you, like this. From there we can copy alpha. This will be like alpha. Okay, so this object alpha will be like this visual angle when the object is placed at D from the eye. Okay, so tan alpha will be HO by D. Okay, now what is beta? For calculating beta, this is the object. Okay, now if this is the object, for the position of the object, this distance will be the object distance. This distance will be the object distance. Suppose this distance is u suffix e. This distance is u suffix e, means this u suffix e I am representing here as the object distance between the optical center and this object. And what is the, okay, this is UE. Okay, fine. Okay, and remember this beta is very small angle. Okay, beta is the small angle. This beta is very small angle. Very small angle. So if this beta is very small angle, so now remember, not write tan beta first. Basically we want to find beta by alpha. Why I am calculating tan beta, you will know. So tan beta from this triangle will be HO divided by UE, perpendicular divided by base, HO divided by UE. Okay, now I told you that if beta is very small angle, then tan beta can be written as beta. Can be written as beta. Okay, tan beta can be written as beta. So this tan beta can be written as beta. So you can write beta is equal to H0 by UE. In the same way, tan alpha can also be written as alpha, and alpha becomes HO by D. Now find the magnification. You have alpha. Suppose this is equation number 1. This is equation number 2. Now find the magnification. So magnification is equal to beta by alpha. Now what is beta? Beta is HO by UE. HO by UE. This is divided by HO by D. So this HO and HO will be cancel out. So the magnification of the simple microscope will be D by UE. D by U suffix E. So this will be the, yeah.
Sir, can you explain how you got tan alpha is HO upon D?
Okay.
H0 upon D.
Okay. This tan alpha, na? I told you that alpha is the visual angle when the object is placed at a distance of D. D means this D is basically 25 centimeter. Okay, least distance of distinct vision. So this angle is alpha. Okay, now do you know tan alpha? What is tan alpha? Tan alpha in trigonometry can be written as perpendicular by hypotenuse. Okay, if you are placing the object, see first see the concept. What is alpha? Alpha is the visual angle when the object is placed from the eye at a distance of d, that is 25 centimeter. So this is the object and this is the eye. This object is placed at a distance of 25 centimeter or d distance. Okay, so this object is subtending at angle of alpha at the eye. You want to find tan alpha from this triangle. Now this is the triangle. From this triangle you will get tan alpha. Tan alpha will be perpendicular divided by base. In 10th class trigonometry, we have what is tan alpha, what is sin alpha, what is cos alpha, what is sec alpha, cosec alpha. So there we studied tan alpha is perpendicular of the triangle divided by base of the triangle. So this HO is the height of the object and this height of the object is the perpendicular of the triangle. And this distance D is the base of the triangle. So that is why I have written tan alpha is equal to perpendicular, that is HO, divided by D. Understanding?
Yes, sir. Yes, sir. Got it.
Okay. So finally, the magnification of the simple microscope, you will get M is equal to D by UE. D by UE you will get. Now we will talk about the maximum magnification. Now we will talk about the maximum magnification. This is the maximum magnification of the simple microscope. Now for this simple microscope, what will be the maximum magnification? So see, maximum magnification. For the maximum magnification, always remember that one point, final image will form at D. Final image will form at D. D means least distance of distinct vision, that is 25 centimeter. When the final image will form at D, then there will be the condition of maximum magnification. And how we will calculate the maximum magnification now? Now image is forming at a distance of D. Now here you can see, here the image is forming here at some distance and object is here. Okay. So now see, this object distance is UE. So this UE is here and this UE we will take negative. Why? Because this is in the opposite direction of the incident ray. Okay. So object distance we will take minus UE and image is forming at a distance of D. And image will form on the same size, same side of object. Then
Sir,
we
why
will
didn't you took,
hello?
sir, why didn't you took minus UE before?
Why we are taking minus UE? Because now you can see I told you the sign convention. In the sign convention, I told you there the direction of the incident light will be positive. So incident light is in this direction. See here. Okay. So this direction will be considered as positive. Means if you will measure the distance in this direction, that distance will be considered as positive. Or if you are measuring the distance in this direction, that distance will be considered as negative. Now I told you distance will always measured from the optical center. So this will be the optical center and you want to measure the object distance. So object distance you will measure in this direction, na? And this direction is the negative direction. That is why UE you are taking negative. Understanding?
Yes, sir.
And image is also forming there in this side. Then if you will measure the image distance, then image distance will also be taken as negative. So that is why I am taking image distance as minus D. And why this time the image is minus D? Because this is the case of the maximum magnification. And for the maximum magnification, the final image will form at D. Now there is one formula, 1 upon f is equal to 1 upon v minus 1 upon u. Okay, and f is the focal length of the lens. So 1 upon f is equal to 1 upon v, v is minus d, minus 1 upon minus ue. Okay, from here I will get 1 upon f is equal to minus 1 upon d plus 1 upon ue. From here I will get 1 upon ue, that is equal to 1 upon f plus 1 upon d. Now magnification, what was the magnification for the microscope? D by ue. D by ue was the magnification. So put the value d by ue. Now d and 1 upon ue. 1 upon ue is this. So you will put the value of 1 upon ue, that is 1 by f plus 1 by d. Now you will multiply this d with 1 by f. Now you will multiply this d with 1 by d. So you will multiply, so it will become d by f and it will become 1. So finally you will get magnification 1 plus d by f. So this will be the maximum magnification condition. Okay. Now there is another case for normal adjustment or for the relaxed eye. For the normal adjustment of the microscope or the relaxed eye, for the relaxed eye, what will be the magnification? Case number second. Case number second. So for normal adjustment or for the relaxed eye, remember, for the normal adjustment or for the relaxed eye, the image will form at infinity. Final image will form at infinity. Okay. So here final image will form at infinity. If the final image will form at infinity, so you can say the image distance you will take as infinity and object distance will remain same, that is equal to minus ue. Okay. Object distance will remain same, that will be minus ue, but this time image is forming at infinity. Now again apply the formula 1 upon f is equal to 1 upon v minus 1 upon u. Now 1 upon f is equal to 1 upon infinity minus 1 upon minus ue. So from here 1 by infinity is equal to 0. Okay. So you will get 1 upon ue is equal to, you will get 1 upon f. 1 upon u suffix e, you will get 1 upon f. Now what is the magnification for the microscope? D divided by ue. Okay. Now 1 upon ue is 1 upon f, so magnification can be written as d by ue, and 1 upon ue is 1 upon f, so magnification can be written as d by f. F is the focal length. Okay. So this is the simple microscope we have. Okay, so take the screenshot properly. I am zooming out and then write in the chat box only small d. Okay. Okay.
Sir, can you scroll little up?
This one?
Yes, yes.
Okay.
Okay, done.
Okay.
Yes, done, sir.
Okay. Okay. Okay, good. Now we will discuss compound microscope. So with diagram, I will explain what is compound microscope. So here is a objective lens, and here is one more lens that is bigger than the objective lens, that is eyepiece lens. Okay, two lenses are there in a compound microscope. One is the objective lens, and another is the eyepiece lens, and eyepiece lens is the bigger than the objective lens. Okay. Okay. So this is the condition. Objective lens, eyepiece lens. Objective lens. This objective lens have a small focal length. Yes. Actually, you actually for the second case and for the first case, for the first case, the case first is this case number first is this. Okay, maximum magnification. So in this case, the final image will formed at D. Okay, final image will formed at D. means final image will formed at the 25 centimeter distance. You will show this can be that condition. You can show this as a 25 centimeter. But for the second case, what will happen? Final image will formed at infinity. In both the cases, the diagram will be different. Okay, for us, because in both the cases, the image is forming at different positions, so diagram will be different. So this objective lens has a small focal length, and this eyepiece lens has the large focal length. Large focal length. Okay. Now this is the principal axis of both the lens. Okay. Principal axis for both the lens. Okay. Now there is an object that you want to see in this microscope, and how that object will be seen. Suppose this is that object, and this object is in front of the objective lens this time. So actually what happens now in case of the compound microscope, first the objective lens will produces the image of the object. Okay, this is the object, height of the object. So okay, so you can write this as O as the object. So this object is in front of the objective lens, and this objective lens first produce the image, okay, of this object. So see how the image will be formed. First we will draw the straight lines like this. Okay, now we will draw the image from this object. Two rays will be required for the image formation. Many times we have done. First ray is parallel to the principal axis. It will pass from the focus of the lens, will pass from the focus of the lens, okay, like this. And another ray from the object will pass from the optical center another ray from the objective lens is passing from the, okay, it will be like this, huh? Like this. So basically this is the image formed by the objective lens. Here somewhere here the image is formed by the objective lens. Okay, so we can show the image formed by the objective lens. This will be the image. This object is suppose A dash and B dash, and this image is, oh, this object is AB, and the image is formed as A dash comma B dash. Okay, and other rays I am removing. Okay, these rays I am removing. There is no requirement of, so we can remove it. So this is the image formed by the objective lens. Okay, and this image is real and inverted. Now, this is the eyepiece lens. This is the eyepiece lens. This is the eyepiece lens. For this eyepiece lens, this image will work as an object. For this eyepiece lens, this image will work as an object. Now this eyepiece lens will form another image of this object. So now we will draw the ray diagram for this object. Okay, so first ray from this will be parallel to the principal axis, and if this is parallel to the principal axis, it will pass from the focus. Just a minute. So for this ray will pass from the focus of the eyepiece lens. Somewhere here will be the focus because it is very large. Okay, so eyepiece is very large as compared to the objective. So, and another ray from the eyepiece, this object will be like this. So you can see both these rays are not parallel. These are diverging rays. Okay, these are diverging rays, and diverging rays will never meet. So what we will do, we will produce these rays in the backward direction. So we will try to produce these rays in the backward direction like this, and somewhere here these rays will meet. Diverging rays will meet here like this. Okay, so somewhere here will these diverging rays will meet. So finally the image will form here. Somewhere here the image will form, and image is this time very large image. Somewhere here the image will form. So this is basically A double dash B double dash. So this A double dash B double dash is the final image of this object. So this much large image you will get with the help of the compound microscope. Okay, with the help of the compound microscope, this much large image you will get. First the image will be formed by the objective lens, and that image will work as an object for the eyepiece lens, and that eyepiece lens will produce the final image here. Okay, so we can mark the distances now. If this distance is the object distance for the objective lens, and this distance from here to here is the image distance. Okay, image distance for the objective lens. Now for the eyepiece, what is the object distance? This distance is the object distance, because this image is working as a object. This distance will be the object distance for the eye lens. Okay, and what is the image distance for the eye lens? The image distance for the eye lens will be this distance. Okay, this distance will be the image distance for the eye lens. This distance. Okay, VE. Okay, VE. So in this way, you have to draw the ray diagram. Okay. If you want to take the screenshot, then take the screenshot.
So that is dotted lines, right?
Thank you, Fawaz.
Sorry.
Actually, that will be dotted line. This will be dotted line because these are producing. Okay, these will be dotted line. Sorry. Okay, now you can take the screenshot. Okay, just a minute. I am zooming in, zooming out. Now I think you can take. Okay. Okay, just give me 1 minute. I'm just coming. Now we will calculate the magnification. Okay, now we will calculate the magnification. Magnification is what? Beta by alpha. Magnification is what? Beta divided by alpha. Alpha is this. The procedure to calculate alpha will remain same. This is alpha. Okay, this is alpha. Now, how we will calculate beta and what will be beta? Angle subtended by the final image. Angle subtended by the final image means this will be the beta. This will be beta. Okay. Visual angle subtended by the final image. And what is the final image? This is the final image. Now, tan beta we can calculate from this triangle. Tan beta. So we can calculate tan beta. So tan beta we can calculate. So tan beta can be written as from this triangle perpendicular divided by base. And base is UE and perpendicular is A dash B dash. So we can write A dash B dash divided by UE. Okay. Now after that, for this objective lens, if I want to write the magnification for the objective lens, magnification of the objective lens, what is the formula of the magnification? Magnification is height of image divided by height of object. So for this objective lens, this is the image, this is the object. So height of the image means this distance, A dash and B dash, and A dash and B dash will be taken as negative because this is below principal axis. So it will be minus of A dash B dash divided by AB. And this magnification is equal to image distance divided by the object distance. So image distance is this, in this direction, in the direction of the incident light. So image distance will be taken as positive. So it will be positive. And object distance, we will take negative because this is in this direction. So this will be negative, is equal to U naught. Now from here we can calculate minus U naught. Okay, so we can calculate minus A dash B dash we can calculate, and we will put A dash B dash here, we will get tan beta. So now see how you will get that. Okay, so here it will be A dash B dash divided by AB is equal to V naught by U minus U naught. This will be cancel out. What is AB? AB is just the height of object. Okay, AB is just height of object, nothing. AB is height of object. Now from here you can calculate A dash B dash, that is equal to V naught by U naught multiplied by height of object. This will be your A dash B dash. Now put this A dash B dash here in tan beta. So when you will put this in tan beta, you will get V naught by U naught into H naught divided by UE. Okay, from here. So this is your tan beta, but at the same time tan beta can be written as beta. Tan beta can be written as beta because beta is very small. Okay, and tan alpha can also be written as alpha because alpha is very small. So now we have alpha, now we have beta. What is the value of beta? We have beta is this tan beta is beta. So we can write V naught by U naught multiplied by H naught by UE. It is V naught by U naught multiplied by H naught by UE. Suppose this is equation number 1, beta, and this is equation number 2, alpha. Put the value alpha by beta, beta by alpha. So magnification is beta by alpha. What is beta? Beta is this, V naught by U naught multiplied by height of object divided by UE, and this is divided by H naught by D. H naught by D. This H naught and H naught will be cancelled out. So what we will have? We will have the magnification of the compound microscope, that is equal to V naught by U naught, V naught by U naught multiplied by D divided by UE. Now you can see what is V naught by U naught. V naught by U naught is the magnification of objective lens. So this is this M is equal to magnification of the objective lens multiplied by magnification of the eyepiece lens. This d by ue is the magnification of this eye lens. You can see here d by ue. Okay, magnification of this type. This is the simple microscope. So eyepiece lens is behaving as a simple microscope. Okay. Okay. So this will be the magnification for the compound microscope. Okay, so please write down once, please take the screenshot once again for the calculation part. Okay. For this case also, we will discuss the maximum magnification. Case number 1. Maximum magnification. Now we know in case of the maximum magnification, image is formed at the capital D distance. Final image formed at capital D distance. At T by eyepiece. Because finally the image is formed by the eyepiece, na? So object distance of the eyepiece will be this, and image distance will be this, and focal length of eyepiece will be focal length of eyepiece. So apply this formula, 1 upon f is equal to 1 upon v minus 1 upon u. So it will be 1 upon fe. Instead of 1 upon v, minus 1 by d minus 1 upon minus ue. From here you will get this minus and minus plus 1 upon ue you will get from here. 1 upon ue you will get, that will be equal to 1 upon fe plus 1 upon d. Now the magnification of the microscope is this, v naught by u naught multiplied by d by ue. V naught by u naught multiplied by d by ue. Now put the value of ue from 1 upon ue from here. It will be v naught by u naught multiplied by d multiplied by 1 upon fe plus 1 upon d. It will be v naught by u naught. This d will be multiplied throughout the bracket, so you will get 1 plus d by fe. Okay, so this will be the maximum magnification. Now for the normal adjustment, page number 2. Normal adjustment. So in case of the normal adjustment, the image is formed at infinity. Final image is formed at infinity. Okay. Final image is formed at infinity. So object distance will remain same. That is minus UE. But image distance will be infinity, and focal length of the eyepiece will be focal length of the eyepiece. So you can apply this 1 upon f is equal to 1 upon v minus 1 upon u. So it will be 1 upon fe. This is equal to 1 upon infinity minus 1 upon minus ue. So 1 upon ue we will get 1 upon fe. So now what is the magnification for the compound microscope? That is equal to V naught by U naught multiplied by D divided by UE. UE is 1 upon Fe. So you will get magnification is equal to V naught by U naught multiplied by D by Fe. Okay, Fawaz. So you have to remember, for the maximum magnification, the final image will formed at D distance by the eyepiece. For the normal adjustment, the final image is formed at the infinity. Okay, please take the screenshot now.
Sir, but normal adjustment diagram.
Actually, no, they will not ask you about the diagram for the normal adjustment. Mean this is the diagram for the normal adjustment. Okay, for the normal, not for the normal and normal. I mean, I'm not saying this is a diagram for the normal adjustment. For the normal adjustment, this eyepiece na will form the image at infinity. So you have to show the image like this. You want to show na? So you will show the image like this. It will be like this. Both the rays will go like this. They will never meet. They will meet at infinity. Okay.
So if they ask compound microscope, this we should make parallel rays. Like they should not meet like that.
If they are asking, if they can, if they are asking that, draw the ray diagram for the compound microscope for the normal adjustment. For the normal adjustment, if they are saying, then final image will be infinity. Image will be at infinity. So accordingly, you will draw the. If you know that final image is at infinity, so what you will do? What you will do? So you will draw these final rays at infinity, means you will draw these rays like parallel rays. Okay. Okay, Fawaz.
Okay, sir.